A very pleasant good morning to you all. I welcome you all to the physics online class. I hope you are all safe and good in your home. And today we are going to discuss the next unit number 7, properties of matter. Properties of matter. What is matter? Matter exists in 3 states, right? Solid, liquid and gases. Otherwise we can say solid and fluids. Fluids means what? Liquids and gases are called fluids. Okay. In this chapter we are going to discuss about the properties of solids. Okay. Elastic modulus, elastic behavior, and also we are going to discuss the term stress and strain, and also surface tension, viscosity. All these we are going to discuss in this chapter. Look at this picture here. What you can observe? This is the dam. Okay, Kallanai Dam. It is located at Trichy for the purpose of irrigation. Okay, it is built across the river Kaveri. What is the relation for this dam and our lesson properties of matter? Yes, there is a relation is there. What relation is there? The stability and this utility of this dam is related to the properties of matter. You know, during heavy floods, the velocity of water is generally high. So, in these conditions, also the dam stability is important. No? So, the way of construction and the materials is used is very important for the stability. So, if you learn these properties of matter, so we can understand about the materials, and according to that we can use the materials for the systematic applications. The other example known for insightful construction of the past is the pyramids in Egypt. And also nowadays they are constructing the flyovers and overbridges are common worldwide today. So heavy vehicles fly over in these bridges. You know, always it will goes under the stress. So without effective design using suitable materials, the bridges or flyovers will not be at stability. So to study the properties of matter is very essential in selecting a material for a specific application. For example, in technology side, the material used for space application to construct a rocket. So there should be a lightweight materials is used, but it should be very strong. So like that in medical field, you know, the materials used for artificial human organ replacement, it should be biocompatible. That means what fluids or materials we are using, that it will be equal to the flexibility of our tissues. Okay, then only we can use that materials for the replacements of the human organs. So in each and every technology, whatever we are using, the materials is very important. So if we know the properties only, we can select the material according to their application. So now we are going to learn the important properties of solids, liquids and gases. So microscopic understanding of various states of matter. See, the microscopic understanding of solids, liquid and gases was established only in the 20th century. In the universe, everything is made up of atom. You all know that, right? So, everything made up of atoms or molecules. If so, why the same materials exist in 3 states? So, you may arise the question like this, isn't it? For example, water exists in 3 forms. A solid, ice, in liquid form, water, and gaseous form, it is in steam. But these 3 states of matter are made up of same water molecules. like 2 hydrogen atom and 1 oxygen atom. So physics helps to understand this beauty of nature at the microscopic level. So in this matter, the atoms or molecules determine whether it exists in solid, liquid or gaseous states. Okay. So first we are going to learn about the solids. Okay, properties of solids. In solids, you all know that the atoms and molecules are tightly fixed or tightly packed. So in the solid formation, atoms get bound together through various types of bonding. Due to the interaction between the atoms, they position themselves at a particular interatomic distances. This position of atoms in this bond condition is called their mean position. Here in this picture you can see in solids how the atoms and molecules are tightly packed or closely packed. So in between this the interatomic distance is very less. Okay, so because each and every atom are closely packed together. So the solid have definite volume, definite shape, size. Okay. So in between the atoms and molecules are bonded between the different types of bonding, ionic bonding, covalent bonding, etc. So when we are giving the heat to this solids, it will starts to vibrate from the mean position. Okay. So if you are giving the external energy of the solid, what will happen here? So it will starts to vibrate from this mean position. So in solids, the atoms or molecules are tightly fixed. In the solid formation, atoms get bound together through various types of bonding. What are the bonding? Different types: ionic bonding, covalent bonding, etc. Due to the interaction between the atoms, they position themselves at a particular interatomic distance. This position of atom in this bound condition is called their mean position. So next one we can see in liquids how the atoms and molecules are arranged here. Okay. So comparing with the solids, here the atoms and molecules are loosely packed. In between the atomic distance or the intermolecular forces is greater. Okay, comparing to solids, here the interatomic distance is greater. So in liquids, the atoms and molecules are loosely packed. So if we are not giving any external energy for the solid, external energy in the sense, for example, heat. So it will remain as a solid due to this bonding between the atoms. Okay, if you are not giving any external energy, it will continue the same state of solid. Now when the solids get heated, what will happen? The atoms of a solid receive the energy. What energy? Thermal energy. And it will receiving the thermal energy, it will starts to vibrate about their mean position. When the solid is heated above the melting point, what will happen? The heat energy will break the bonding between the atoms. And the atoms receive enough energy and it starts to move. So here also the intermolecular forces are important. See, but the molecules will have enough energy to move around, so that only which makes the structure, the structure of the liquids, okay, to makes the structure mobile. Mobile means what? The atoms and molecules will starts to freely move around. Next one, in gases. So we can see here the atoms and molecules, how they are arranged in gases. So in between the interatomic distance is greater comparing to solid and liquids. Okay, in gases the atoms and molecules are loosely packed so that the kinetic energy of these gases of the atoms and molecules are high. So freely it can able to move here and there. Okay, so the intermolecular force is very weak comparing to solids and liquids. Now here we can see how the liquid state will be converted into the next state, gaseous state. When a liquid is heated at constant pressure to its boiling point, or what we can say when the pressure is reduced to at a constant temperature, it will be converted to a gaseous state. This process of a liquid changing into gases is called what? Evaporation. Okay, the liquid is heated at constant pressure to its boiling point. So the temperature will be increased, so it will be converted into what state? Gaseous state. This process is called what? Evaporation. So in this, the gas molecules have either very weak bonds, or we can say there is no bonds in between the atoms and molecules. So this enables them to move freely and quickly. So we can say the bond between the atoms is very weak. Otherwise, there is no bond is there between atoms and molecules. So that only it can make the atoms and molecules to move freely. Hence, the gas will conform to the shape of its container, and also will expand to fill the container. Okay. So, the gases does not have a definite shape and volume. Okay. So, when we starts to heat, it will conform to the shape of the container and also will expand to fill the container. Atoms and molecule will freely move, isn't it? So, it will starts to expand and to fill the container. The transition from the solid to liquid and from liquid to gaseous states, it is due to the external energy. Okay, depending upon the external energy, it will be changed from one state to another, solid to liquid and liquid to gases. So here you can see the schematic representation of the transition from solid to liquid and liquid to gaseous state due to the change in the external energy. Okay. So in this picture we can see the different states of matter, solid, liquid and gases, and also we can observe that how the atoms and molecules are arranged here, right? So due to the change in external energy, so it will be converted into one state to another. Okay. So here today you learned the microscopic understanding of various states of matter. Okay. So this question today you have to learn and write it in your assignment note. Okay.